Why is a system boundary critical for system modeling? Imagine trying to understand a machine without knowing where it begins or ends. It's like trying to solve a puzzle with missing pieces. That's where a system boundary comes into play. It's the line that separates what's inside the system from what's outside. This boundary helps us focus on the parts we want to study and ignore the rest. In system modeling, especially in advanced topics and system dynamics and control, defining this boundary is essential. It tells us what elements, energy, and matter flows we need to include in our analysis. Without it, we can't accurately predict how the system behaves. For example, if you're analyzing a car engine, the system boundary might include the engine block and internal parts. But it might exclude the surrounding air or fuel supply unless those are part of your focus. This distinction makes the model clearer and easier to work with. The boundary can be a real physical wall or just an imaginary line chosen based on what you want to learn. It's flexible and can be fixed or movable, depending on your goals. For control systems, knowing where the boundary lies helps you understand how energy and matter move in and out. This is key for balancing energy, tracking fluid flow, or understanding heat transfer. If you don't set a clear boundary, it's impossible to tell what inputs and outputs influence the system. This makes your model unreliable or incomplete. Setting a boundary helps you decide which parts to include, which processes matter, and which can be left out. It also helps you understand if your system is closed, open, or isolated. This affects how you treat energy and matter exchanges. Plus, it provides a framework for applying laws of conservation and thermodynamics. In short, a system boundary defines the scope of your model. It helps you analyze and control the system more effectively by clearly showing what's inside and what's outside. This clarity is what makes system modeling accurate and useful for engineering and design.